All right. Well, hey, welcome to the weekly Space Hangout, everyone. My name is Fraser Cain. I'm the publisher of Universe Today. And we've got our regular crew of space guys, but we've also got a special guest this week. So I am pleased to welcome Paul Gilster from Centauri Dreams. Did I say that right, Paul?
That is exactly right.
Woo! Okay, so for those of you who aren't aware of Centauri Dreams, open up another browser tab right now and key into to Paul's blog. So one of my absolute favorite space websites. In addition to reporting on all the cool space news, Paul also is a huge advocate of interstellar spaceflight, and not just like the Star Trek variety, but actually trying to figure out how to any of this kind of sending interstellar probes is actually feasible. So we'll be talking to Paul quite a bit for the first few minutes of the show. But of course, we've got our regular crew as well. We got Dr. Brian Koberlein.
Hi, nice to be here again.
We've got Dave Dickinson, who has been somehow released from his from the basement to the kitchen, and is sporting a jaunty mustache. You know what? We can't hear you, David. No, you somehow muted yourself. And we've got Morgan Rehnberg. Hey, Morgan.
Hey, Fraser.
All right. So this week, in addition to talking to Paul, we are going to talk about so many tabs. What are we going to talk about? Probably SpaceX. Let me just look. Yes, we're going to talk about SpaceX. This is This Week in Musk, of course. We're going to talk about possible oceans in Enceladus and how salty they might be. New imaging of from Cassini, the upcoming Black Moon, the number of reachable asteroids, stars forming earlier than we thought, dark matter seen at the middle of the at the center of the Milky Way, and other stuff. So, did that work, David? Are you able to talk now? You're muted now.
I think I am.
Oh yeah, but it looks like you've changed your microphones. Yeah. So before I
did. Maybe that was the problem.
Okay. Well, before we get started, I also want to let you know that you can. This is an interactive show. You can talk to us, and so the way you do that is use the Q&A app with YouTube. So if you're watching the show, it says that Fraser is interacting with the audience, and just click that link. You can go into the Q&A app and you can post a question. You can post a question for the stories we're talking about today, or post a question for Paul. And I promise you, once we get started, you're going to have a million questions for Paul, because you love this stuff as much as I love this stuff. So, and I'm going to say hi to Hugo Burnham, Nancy Graziano, Tony Lynch, Sev Dust Bunny, Bert Wolters, Andrew Planet, Will Idoni, Peter Waldman, everyone, Gazelle Submarine, who else is here? And Michael Jobin. So hey, Weekly Space Hangout crew, we really appreciate you joining us. All right, well, let's get on with the special guest portion of this show. So Paul, can you give people sort of a bit of a background on who you are and what you do?
Sure. I began Centauri Dreams in 2004. I had just finished a book of that title. Before that, I was a technology writer covering a lot of things related to the internet and so on. But aerospace and astronomy had always been a key interest of mine since growing up. And I thought, well, let's turn to that now and really look at where the tech is in this field. And Fraser, the original impetus was to look at something I had just assumed was impossible, which was starflight at this stage of our civilization. And surprisingly discovered there was a lot of work being done on this that was not well known. So I started digging into that, and that really led to the beginnings of the Centauri Dreams website in late 2004. It's been going ever since. Mostly, I try to keep it 5 times a week. Some weeks don't work out quite as well as that, but my surprise has been that there's never a shortage of things to write about, and that, as you know, being in the business, is accelerating.
You have no idea. Well, yeah, I guess you do have idea.
I do
but
have
it
an
is-
idea.
Yeah, it's hilarious because this is literally what I've been coming to grips with in the last couple of weeks, couple of months. Is just like there's too much going on. There's too much news. There's too much for us to really try and handle. And I'm literally trying to change the way that I deal with this kind of stuff because it's too much. Like
Yeah,
Twitter
I'm
feels like a
making
better
the same
place.
thing.
Yeah. So I think let's go back to the interstellar probe part about this.
Sure.
And so, we're so focused on the news, and a lot of this is what comes out of the news agencies. And as you know, like NASA will release a press release about the astronauts doing a spacewalk, and then that'll get picked up 30 times, and people will report on it. But for the people who are dealing with these deeper questions of how do you get a spacecraft from the solar system to perhaps one of the nearest star systems, what is the engineering required, that doesn't get the same kind of publicity from NASA and those guys. And so that research really goes unseen, unsurfaced, because they just don't have the same kind of public relations. So what is the sort of, what is the state of sending spacecraft to other stars?
What I discovered when I began looking into this was that there were quite a few scientists and engineers who were very serious about it, but there was no concerted effort to do it. There have been a couple of programs within NASA and within other space agencies, ESA in particular, but nothing of a really major effort other than breakthrough propulsion physics, which was done in NASA in the late 90s and early part of 21st century. So as you look into all that, I begin to realize here's the story. I mean, what I'd like to do is bring these people together. They meet maybe once a year at a conference, and the conference is not devoted to interstellar space. So they get out in the hallway and they have conversations. And I was hoping to create a site where people like that could talk, get to know each other more, exchange ideas, and in particular, get these ideas out to the public so that we start to make the case that there is a story behind the more immediate story. Now, I cover the immediate too, and so we look at all the exciting stuff like Pluto and New Horizons. I don't want to shortchange any of that. But I see it as an evolutionary scenario where what we're doing is creating the foundations for ever deeper penetrations of the solar system and eventually out into nearby interstellar space. Here we're talking about timeframes that could be millennial, could be at least centuries in my view. And so the challenge there is to try to awaken a long-term thinking spirit that I think we once had as a culture, but my other great interest is in the past, and in particular early Europe, where I think that spirit was maybe a little more relevant than it is today, because today we're in this era when everything is done on the basis of quick returns. So it's a matter of melding the excitement of the immediate with the need to really look at a long-term solution and to say what small steps can we do today that over time begin to gradually translate into the outcome we want.
So what kind of mission profile do you think we would be looking at based on our current thinking to, say, send an actual probe to a nearby star?
Sure. If we looked at it today, I mean, if we decided, well, we need to do it within this century, say, or maybe within the next 50 years, we're looking probably at a flyby probe, something that could be boosted to the kind of speeds we need, and even that's going to be very hard with our current technology. But if we could find a way, perhaps through beamed propulsion to a light sail or something like this, to get up to a few percent of speed of light, we're probably looking at a flyby that's not going to have the ability to decelerate. And we could, I think, theoretically do that within 50 years. The question would be, is that good enough? Because right now we can learn a lot about exoplanets and their systems right here from our solar system. So I think we need to be looking at missions that rendezvous with their target. Here the demands are much greater. you have to carry a great deal more fuel or work out a better strategy. This might take us a while longer. My personal favorite, Fraser, would be some kind of enormous sail. We've seen the Icarus Japanese sail. I'm talking about one propelled by laser or microwave rather than solar radiation. And if we can get the materials in place, learn how to beam a powerful laser on something like that, there the possibilities start mounting up. And I think that's going to be the early steps. But even before that, we're going to need to learn how to explore the rest of our system. You know, we're technically getting a little bit outside of it with our Voyagers. But heck, there's the Kuiper Belt to be looked at. There's the Oort cloud much farther than that. That may go out 2 light years. Trillions of comets. It may actually intersect with a similar cloud around Alpha Centauri and those stars. So we've got a lot to learn by way of preliminary precursor missions first, just so we understand what we're trying to do.
Do you think, and like I know that NASA's advanced concept people are working on some pretty interesting ideas. I know Sonny White is even working on a concept for a warp drive.
Right.
So I think it sort of surprises people that NASA is considering this stuff. I mean, these ideas they're out there, but they're still considering them.
Well, they are, but here's the deal. When we had breakthrough propulsion physics, which Martin Millis used to run back in the late 90s, very interesting program. They had a wonderful conference. They brought really top guns in these exotic fields into the mix, but the funding was very small, and the program was discontinued. The current program at Eagle Works down at Johnson Space Center is also funded on a shoestring. So we're not seeing anything like the kind of funding that might really give us breakthroughs in truly advanced propulsion. And here I'm talking about things that we don't know how to do. They're beyond currently understood physical law, like warp drive. Where I think we are going to see tremendous strides made in the next few decades is in those things that do fit with our current concept of physical law. Here we've got some real possibilities. Fusion may or may not come along. I'm pretty skeptical about fusion, but if we do harness it in an engine, that's one possibility. But I mentioned light sails, some kind of sail driven by microwave or laser. That's another one. And there are a number of these ideas that all of them work within Einsteinian general relativity. We think we know how they could be made. The question is that small problem of engineering, because we're talking about enormous things that are very hard to make, and they need to be made in deep space and maintained in deep space. So that's our dilemma. And in terms of nearby missions in the near future, that's quite a road, quite a challenge for us.
Right, and so when I'm kind of imagining the infrastructure for this kind of a mission, that you're using a light sail, some fairly lightweight probe that has got a very large light sail, and then you've got laser systems set up in the solar system, and then you bring the spacecraft close to the sun, start to accelerate it, and then the lasers start firing and accelerate it up to significant portions of the speed of light, right?
Exactly. I mean, the ideal here to do would be to bring your sail in very close to the sun. It's called a sun diver orbit. You're practically skimming the photosphere of the sun. Gives it a tremendous amount of acceleration. And then as it is receding from the solar system, now you bring into play your enormous beam of laser or microwaves upon it. Try to give it a real kick to add to what it's already got. Really bring it up to a much faster speed. And that would be the scenario. You're not going to have this beam on it the whole way to the other star. You're going to be giving it an early push and then shutting it down. You might actually furl that sail along the way and perhaps redeploy it as a way of slowing down upon entry. Or there are other ways you might slow down on entry that involve pushing against the so-called stellar wind from the star, the particles that it's putting out. There are a number of things you could do. But yes, that's the scenario. And it has been extensively studied back in the 60s, the 70s, and 80s. by a man named Robert Forward and many colleagues of his who I write about on Centauri Dreams all the time. And I'm happy to say I've become friends with many of them, and we talk about this all the time. So the concepts are there. I think it's very exciting, and I just want to get them out there where people know they're there and can think about placing them in a long-term context of how we might do this, while at the same time not abandoning the possibility that we may someday find something that goes beyond our current understanding of physics and makes it a lot faster still.
Now these are robots. These are, sending fairly lightweight autonomous probes but I think for a lot of people, they really want the idea, Star Trek promised us that we would hop in our spaceships and we would fly to other worlds and colonize them. Are people ever are we going to take our meat to another world, or is that just never going to happen?
I hope we can do that. I would love to think we can. Of course, it's a tremendous push. Almost as big as the propulsion problem there is the question of how you maintain a life support system, closed support system. For a long time, we know surprisingly little about how to do this. Now, so there's a lot of things to learn. If we could get missions down less than a century, then maybe we could start talking about this. Or if we want to start doing human missions on an entirely different time frame, I think it's very possible that in the future our species is going to gradually spread into the solar system using enormous habitats of the kind that Gerard O'Neill studied back in the 1970s. These would be like enormous cylinders where you could create a very livable environment inside them. And if they become alternatives to how people live in the solar system, maybe some people don't want to live on a planetary surface. Eventually somebody's going to say, we're doing pretty well in here. Why don't we set out for another star system? And it might take us a couple of thousand years, but we like where we're living. Let's just keep our civilization going, and someday we'll get there. Now that's called a world ship, and it's a millennial journey. I kind of think if it ever happens, the people who get there will study that new world and get very interested in it. And when they're through, they may well say, we don't really want to live on a planet again. Let's shove off again. So that's another alternative for how you might do it. I'm convinced we're going to do it. I'm convinced we're going to get people out there, but I'm not sure how long it's going to take.
Yeah, if we don't do it, it'll be because we've created artificial life forms and they've turned the entire Earth into computronium, and then they're now expanding through the universe at the speed of light and turning everything into computronium. So whether we do it or our robot descendants do it, it's gonna happen. We hope.
I think so. I think it's in our future.
Yeah, and I think what's great about this is to say, this is the goal. Let's build an infrastructure in the solar system that is capable of accelerating spacecraft to fast speeds, and then a different infrastructure maybe still in the solar system that is capable of decelerating spacecraft. That when you start to think about that question and say, how are we going to move people around the solar system at the kinds of speeds that make it useful, then you're looking at different kinds of infrastructure, different kinds of challenges, and the kinds of things that human beings need to face. And so I think it's great
I love your idea here, because essentially I think we are going to at least expand to the edges of the solar system just because of the imperative of locating objects that might be on a dangerous course, that we might need to change their trajectory to avoid a future impact. That might mean getting deep out into the solar system and being able to send people who can operate for long periods of time around these objects to change their trajectory. If you do that, and I think we have to do that, but if you get to that level, then you have gone a long way toward developing the next step. And my view is that this is going to be an incremental process. I don't think we're going to suddenly say, let's build a starship. I doubt that. I think we're going to say, let's continue to do what we have to do here, and as we start doing things like asteroid mining and asteroid deflection, and as we start sending our exploratory missions within the system, the expertise follows. And at some point, you go maybe out to the Oort cloud and you start mining resources there. Gradually, you're diminishing the distance to the next stars. And at some point, it becomes less of a challenge. I see that as incremental, step by step, and building to the outcome I think we all want.
Yeah, I mean, your cloud could very well extend a light year out from the Earth. So
It could indeed.
yeah, so it's, if you can actually work within the Oort cloud, you're doing a pretty good job. Well, we've got to move on to the rest of the show. I really appreciate you joining us. For starters, how can people find out more about what you're doing and your website and stuff? So where do they find out more?
Oh, kind of you to ask. It's centauridreams.org, O-R-G. That's centauri-dreams.org. And I'm affiliated with the Tau Zero Foundation, which Mark Millis started when he took early retirement from NASA and left what had been breakthrough propulsion physics to study these things outside of NASA. So we're not connected to NASA anymore at all. There, they can go to www.tauzero, all one word, T-A-U-Z-E-R-O, and then the suffix is aero, A-E-R-O, which is the aerospace suffix, and that will get both those sites between them will give you what you're looking for.
That's great. And if people want to be a part of the Tau Zero Foundation, of being a part of joining some of these conferences, like where do these happen?
Conferences these days are starting to proliferate. We had quite a few in the last few years. I try to publish a notice about them every time one of them is coming up on my site, so that would be a good place to start looking. And as far as going to one, all you have to do is click the link and take a look at it. If you want to go, they're open.
Yeah.
Now, some of them have a limit on how many people can get in. But we've had quite a few people from the general public with a great interest in space coming to take a part in it, and in many cases really provide helpful comment and direction. So we welcome that. There are other organizations like Icarus Interstellar, the Institute for Interstellar Studies. We're all trying to do the same thing here to awaken public interest. And people out there are welcome to join in this effort, and we hope they will.
Yeah, our good friend Ian O'Neill from Discovery Space is
Right.
involved in Icarus, I think. And
He is. Ian is a big player in Icarus and a
Yep.
very good writer.
Yeah. All right. Well, awesome. So feel free to stick around if you want. If you want to talk about some space news, that would be great. And if you need to move on and keep working on your interstellar spacecraft, we totally understand. All right, Morgan. What's going on this week in Musk?
Yeah, that's right. So last week we were talking about how SpaceX was preparing for the next launch of a NASA satellite, as well as preparing for their next test of landing the rocket on a floating platform in the middle of the ocean. And the good news is that one of those two things happened this week. After several delays that were mechanical, instrumental, and even weather-related, they finally were able to launch NASA's Discover spacecraft the other day, and this spacecraft is now well on its way to the L1 Lagrange point between Earth and the Sun, where it will take up station and monitor the Sun for space weather purposes. Unfortunately, however, the Falcon 9 wasn't able to attempt a landing on the floating platform because the weather wasn't good enough downrange at the ocean. It was fine on the launch pad. They were able to get the launch off flawlessly, but the weather wasn't sufficient, and so they basically had to ditch it in the ocean like they did on previous attempts. The other news that came out from SpaceX this week is that they signed a 5-year agreement with the U.S. Air Force for landing pad facilities at Cape Canaveral. And so this is sort of indication that the Air Force believes that SpaceX is basically going to succeed with this sea-based landing and will be ready to graduate to landing these rockets back on land. And that's really the next big step, because once we can bring them down on a landing pad on Earth, then we can start to look at them, and engineers can determine, well, what are the effects of the launch, what's going to need to be replaced, what can just be basically reprimed and refueled, and it won't be until we can do that that we truly have an idea of how reusable these things actually are going to be. But
Yeah, I mean,
progress is being made.
the irony of yesterday's launch was that the reason they couldn't land was because the ocean was too wavy and the weather was too bad.
Yeah.
So, but if they were landing back on land, as they planned to eventually, they probably would have been able to make the landing.
Right,
So,
if the conditions are good enough for launch at the launch pad, then they'll also be good enough for landing at what is essentially the same location. And so once they can get past this ocean hurdle, they should be in really good shape to bring these things down pretty reliably.
yeah.
We did some brief research on this one too, and we noticed that this was the most distant launch that SpaceX has gone for. They've gone for geosync, but they've never gone for the L1 point, which is 1,000,000 miles away. So I didn't know that the Falcon 9 could reach that, actually. I was kind of impressed.
Huh, that's really great. All right, let's move on. David, the Black Moon.
Yeah, I've seen this term coming up. It's kind of a, like blue moon and supermoon is kind of a pseudo-astronomical term. It's not something.
Oh, did we lose David there?
Looks like we might have.
Oh, but only David. All right. All right. Well, while David is clearly they've got to him, and
The Black Moon cometh.
yeah, and he's not allowed to speak the truth. So, man, this is just going to feed all the conspiracy theorists. All right. Well, Brian, let's move on to stars forming earlier than we thought, and then
Okay.
later on when we'll extract David from whatever prison compound he's been sent to.
Okay, it's actually stars forming later than we thought.
Oh, sorry,
I'm
later than we
apparently
thought,
missing
not
it.
earlier.
So
The opposite of what I said.
the opposite. This is actually more interesting things you can get from the Planck data. So, for those who aren't familiar, the Planck data was looking at polarization in the cosmic background and doing an all-sky survey. And a lot of it has been focused on early cosmic inflation, whether or not you could detect that. But the other thing is looking at the early stages of the universe and how things form. And in this case, what they did is the polarization that we see, most of the polarization comes from what's called last scattering. In other words, when the early universe is really hot, all the light is bouncing around against ions, and eventually it cools just enough that it becomes transparent, so about 3,000 Kelvin. And that last scattering that the light does is what polarizes the light, and that's what you look at for things like gravitational waves. However, after that first cooling, once it's kind of cooled down, you enter this period of what we thought was about 400,000 years, where it's gotten too cool to produce light from the Big Bang, but there hasn't been enough time for stars to form and galaxies to form so that you've got kind of second light. So you don't have any light in the universe after that point. And so this is a period that we call the Dark Ages, between the Big Bang and the first shining of the stars. And we've thought, based upon other observations, that this is about 400,000 years. 400 million years. And what we're finding is that if you look at the cosmic microwave background, if you look at the polarization in that, you can see where the light from the Big Bang then hits stuff that's been reionized. So when new stars form, when the very first stars form, they heat gas and stuff around them, and that causes the light to scatter off of that now too. And so you can see the difference between the cosmic microwave background and this kind of scattering from the first stars, what's called reionization, when you're finally getting that. And we have enough precision now that we can time it. And from Planck, what we find is that reionization occurs around 550 million years, not 400 million years. What's interesting about that is that around that 550 million years is about the time when galaxies are already kind of in place, as it were. So it really points at the idea that the kind of proto-galaxies were already kind of rigidly kind of locked in as the stars were just starting to form. So it wasn't a matter of stars formed early and then came into galaxies. It's a matter that the galaxies were forming at the same time that the stars were forming.
Does this give us any insight into this question, like what came first, the galaxies or the supermassive black holes at the heart of them?
I don't know that it does that by itself, but it very clearly narrows the question, because it very clearly says that when stars were forming, when reionization occurs, that is the time in which there were also galaxies. So the idea that you could have large galaxy clouds with primordial black holes and then stars forming out of that is not against what we see in the data. That's
But it's weird.
possible.
It's weird to think of a galaxy without, because a galaxy is made of stars, and yet there were no stars.
That's how we define it, yeah.
Right? We call a galaxy is a collection of stars, and yet there were no stars. It's just like what was going to form stars.
Right, and I think if you look at that early part of the universe, you could think of it as a kind of coalescing of a galaxy's mass worth of material that's already clumping there, driven largely by dark matter, but it's already clumping there, so that when the stars form, they form within galaxies. They don't form spread out and then collapse into galaxies.
And I know you actually talked a few months ago about what some of those first stars might have looked like, and they were monsters, right?
Some of them would definitely be monsters, yeah. And that's we've got other evidence from other things not related to this, but they're showing that the material that was seeded in the universe, the higher elements formed within an early stars, also appeared early too. And so it looks like that right in this time you would have really large stars forming in galaxies. They last for a very short time and then cast off their heavier elements. So when things finally leave the dark ages, when we finally get going, things seem to go very quickly on a cosmological scale.
Wow, fantastic. All right, well, again, while David continues to wrestle with the aliens that have abducted them. Oh, you know what? It's Friday the 13th today. So that really is going to help explain it. We'll move back over to Morgan, and why don't we talk about Enceladus's oceans? Its salty, salty oceans.
Right, so we've known now for about a year that Enceladus has a body of water underneath its surface. We suspected this now for about a decade because we've seen these plumes coming off of the surface of Enceladus, but it wasn't until about a year ago that we had solid evidence, direct evidence of that ocean itself. The ocean's different than, say, the ocean under Europa. Enceladus's ocean is localized to just the South Pole region of the Moon, where all of this heat seems to be located. That's different from Europa, where we think there's probably a global ocean underneath the surface. But we're still unable to really study the ocean directly without landing and going into it. So we're stuck trying to understand it based on what we can see from the plumes. And so over the last decade, Cassini's been making a lot of observations of the composition of these plumes. And we find that they're nearly entirely water. But we see other chemicals coming up with the water as well. And so what this group of researchers has done is take what we've seen and apply basically a model to suggest what might be underneath the ice in the ocean that will then result in the plumes that we see. Because you can imagine that just like when you boil a pot of water, not everything that's in the pot rises out of the pot into the water vapor. You get mostly water vapor, and you might get some salts and other things that come out, but a lot of what's in the ocean is going to stay behind. And so what they've concluded is that based on the observations that Cassini has made thus far, the ocean underneath the surface of Enceladus is extremely salty. Much, much saltier even than oceans here on Earth. So oceans on Earth are somewhere around a pH of 8. That tells you basically how acidic or basic your liquid is. And we're talking here for Enceladus of a pH of somewhere between 10 and 11, which is it's a log scale. So this is a very substantial increase in the salt content. But interestingly, there are bodies of water on Earth called soda lakes that have a pH in this same range. And so it's not a completely alien idea to have this super salty body of water. And here on Earth, in those lakes, we find life. We find lots of bacteria living in these conditions that are extremely, extremely salty. But what this says about the possibility for life on Enceladus is pretty difficult to gauge because the energy source used here on Earth in those lakes is typically photosynthesis, which is turning sunlight from the sun into energy that can then be used by bacteria. And of course, if your ocean is trapped deep under the surface, there's not going to be any sunlight penetrating down there to allow for photosynthesis to occur. But this basically gives us a sense of what the ocean underneath the surface might be like, and where we ought to be looking here on the Earth to try to better understand the oceans that we see out in the solar system.
Right. And so, I mean, we see, like with the black smokers, we see environments where exotic forms of life are using chemical energy instead of necessarily solar energy. So the the models exist. We just haven't seen those two pieces get put together yet.
Right. We know that life can exist in these extremely harsh conditions. The real question that we don't yet have is, can life arise in these conditions? Because we see things like the black smokers, which are hydrothermal vents on the bottom of the ocean. We see these photosynthesizing bacteria in these extremely salty lakes. But nobody really thinks that that's where life arose on Earth. It probably arose somewhere where the conditions were easier, and then over time adapted to live in these extremely harsh environments. And so even if life could live on Enceladus, the question remains, could it have arisen there? And that's something that we're still not really at a point where we can answer.
Got it. Dave Dickinson, you've returned with... we thought you had been abducted by secret forces. You're ready to now tell us the terrifying truth about the Black Moon.
I think I can. Let's see if I can do it before my internet decides to crash again. Yes, we have a new moon coming up. We've noticed that this term has been coming up lately, along with blue moon and supermoon. It's kind of a pseudo-astronomical term that's kind of entering into the popular vernacular of a black moon. Think of a blue moon only with the new moon, as in a blue moon when you've got 2 full moons, or you've got the third in a season with 4, as the old almanac definition. This is coming around as per the new moon right now, and we have such an occurrence with the very archaic, convoluted type of cycle where this is the 3rd new moon in a season with 4 right now that's coming up this week on February 18th. And it's fairly close to perigee moon, so we're getting a lot of talk about it being a supermoon again as far as in terms of tides. Apparently now every perigee moon is a supermoon, so the term is just like, it's gone on to virtually... it's really getting out of control. But I always thought, if we don't own the term black moon, it's just going to get taken over by the astrologers. So we might as well write about it. And it's a teachable moment as far as, the lunar solar calendars and the Gregorian calendar and the Julian calendar and the synodic period and the anomalistic period and all those neat things to talk about, draconitic months and just archaic terms we like to throw around.
So just for people wanting to make sure that they adhere, that they know how to plan their day and avoid the dark tidings that may happen on the Black Moon. The Black Moon is the... What is
the new moon on February 18th.
The new moon on February 18th. And of course the irony, right, is where should we look to see the new moon, David?
Actually, the only time you can really see the new moon is during a solar eclipse, and we won't have a solar eclipse this month, but we have one next month on March 20th, but you'll have to go to the high Arctic to see it. So
yeah, it's gonna. The path is going to go right between like Iceland and northern Scotland.
All of Europe is going to see, UK is going to see a pretty deep partial eclipse. That's going to be cool. Unfortunately, North America just misses this one, but we do have a partial solar in October of this year coming up that we will get from North America, and 2 good lunar eclipses too. So.
All right, Brian Koberlein, let's talk about what did you want to talk about? I forget. Oh, dark matter seen in the Milky Way.
Oh, okay, the dark matter seen in the Milky Way. This is one of those. It's one more confirmation of dark matter. The basic idea is that a galaxy like ours should have dark matter throughout it. And we can see the effects of dark matter, for example, in how gas and stars move around the Milky Way. Basically, they're moving faster than you would expect with just the visible matter alone. And so that was the original kind of impetus for the idea that there is this halo of dark matter around our galaxy and around other galaxies. Of course, one of the predictions of that is that there should also be in the central region of our galaxy be dark matter. we hadn't before been able to really see this effect because there's so much gas and dust and stars and everything in that central region that it's hard to distinguish the signal from the noise, as it were. But over the past several years, we've gotten high enough resolution data of that central region that we actually can distinguish. And this new paper came out, and it looked at, if you take all of the stuff that we know and all the visible stuff in that central region, and then you compare that with the motions of stars and gas in that central region, there's a very distinct difference. So if you look at kind of, this would be the region where it would be just visible, and this is where the signal actually is. It's just above that 95th percentile area. And so it's a very clear signature of dark matter. By itself, it's not a big deal, but where it comes in is a lot of the dark matter models, if you distinguish between different types of possible dark matter, one of the ways that you can distinguish them is by how they would be distributed in our galaxy. You know, do they tend to clump more toward the center? They tend to be more spread out? Are they along the galactic plane or more in a halo? By looking at the central region, we can start getting data to distinguish between different models. So if we say, is it axions? Is it, you know, some superstring thing? Is it some other idea? We can start combining them.
So which theories would you say that this then provides the most evidence for?
I don't know they have enough resolution to distinguish between them. I think that this one was really just, we have enough data now to say there is decidedly dark matter within the center of our galaxy. So in that central region, we're seeing the effect of dark matter, as we would expect. But being able to say, you know, what that distribution of dark matter is a little bit more difficult.
Right. Okay, and Dave Dickinson, double the asteroids, double the fun.
Yeah, this was something interesting. It came out of NASA, JPL, out of a system known as NHATS, which stands for this is an acronym of an acronym, which the government is known for. It's NEOs for Human Spaceflight Accessible Target Steady, which noted that the number of possible asteroids that we could use for human exploration in the next decade or so has doubled from 666 in the first NHATS study back in 2010 out to 1,346 as of February 11th when I looked at the database, when I wrote the article. It's probably even increased now. This system is actually looking at the JPL database and all these asteroids that are being discovered, and it pans through them and sifts through. What they're looking for are asteroids that would be easier to reach than Mars, and in some cases are even easier to reach than lunar orbit. There's about a dozen in there. It was an interesting little database to play with that we could actually reach, and this is the next big thing. You know, they just did the EFT-1 Orion spaceflight to test the Orion spacecraft last year. And the SLS is supposed to go and be ready by 2017, I believe it is, for the next launch to put the whole system together. This is the next big thing that the Obama administration is pushing right now. Of course, it's going to have to weather several changes of U.S. administration. They're thinking the first mission to an asteroid might be 2023. There's ideas to maybe capture one and put it in lunar orbit and then send human explorers out there. But this is something we're looking at over the span of about a decade or so. But it's interesting as systems like the Linear Survey, the Pan-STARRS Survey, the LSST is coming online by 2020. They're finding a lot more of these asteroids out there that we could possibly go and explore. And a lot of them, some of them are a couple kilometers across, and some of them are smaller than a house. And some of these are actually turning out to be returning space junk. I know I've written at least 2 articles in the last year where they found these boosters that were from either the Apollo programs or from a lot of the uncrewed launches that went out that are still out there in solar orbit. And the key is they want to find asteroids. What really filters this down is what your relative delta V coming back to Earth. The Apollo missions coming back had a reentry velocity of about 11 kilometers per second. And that's going to be about the gold standard returning from solar orbit. You're going to need to find these asteroids out there where you're going to have a low enough delta V that you can have a reentry coming back to Earth with using, you know, a minimum amount of energy coming back. So that's what's really filtering out. They're looking for these types of asteroids that have a low delta V relative to Earth.
Right. Yeah, I don't think people really realize that, you know, when you say the delta V, right, the change in velocity that you have to get from, say, orbit around the Earth to being able to get an intersect trajectory with an asteroid, that the amount of fuel that you might require to rendezvous with an asteroid with some asteroids is actually a lot less than what you would need to reach the moon. And so if you looked at the size of the spacecraft, the amount of fuel that you would require, the size and complexity of the rocket, the number of people you get, the number of equipment, it all is better to go after some of these asteroids than it is to actually try and get to the moon. So it's just like it's the cheap way is to go to an asteroid, not the moon.
There was an interesting study that kind of ties in with this. That's why this article kind of caught my eye, about temporary mini moons that occasionally get captured around Earth. We've seen this happen at least once before, and they think it happens a lot of times where the Earth captures an asteroid, and our moon, having a large moon, it actually does a good job goaltending, and eventually it kicks it back out. So we don't keep it for very long. But we saw one in 2006 that did this, that kind of stayed in a looping temporary orbit around Earth before it got kicked back out into solar orbit. And these are very tantalizing targets to maybe go and explore too. They think this happens more often than we think.
Yeah, and they're going to be fairly small, possibly even redirectable, and we can test out some of our ideas for moving asteroids with minimum expense. So this is all great.
But like I said, it's got to weather several changes of administration, unfortunately.
Yeah.
When you're talking about something happening by the 2030s or the late 2020s, it's hard to see what the political landscape is going to be like, and what our new target. Everybody remembers Constellation and what happened with that. So.
I don't even remember Constellation anymore. Okay, well so I got a couple of questions for Paul here, and then I think we got a couple of last few stories. So Paul, this comes from Nancy Graziano. How much longer do you feel before it becomes absolutely critical for our species to have a realistic escape plan from our planet? And do you ever think we'll reach that point?
I do. I think we will reach that planet. Hard to say about timing on it, because we're tracking dangerous asteroids and comets right now, and learning that we can, in most cases, consign them to a danger quite a ways in the future. However, we never know when something might pop up. Now, when I'm talking about preserving the species and so on, unfortunately, we are not going to have for probably millennia the ability to do something like an evacuation of a planet. So we're really talking about, isn't it sensible to spread into the nearby solar system so that we have humans on other bodies by way of small colonies and bases in case something happened? And it might not be an asteroid. It could be some kind of physical experiment gone awry. It could be terrorism with lethal weaponry. Some kind of nuclear war. If we can get these potential colonies off planet within the next 50 years, at least beginning that process, I'm going to feel pretty good about that. I think we have longer than that to do it. What would concern me would be if we simply decided we didn't need to. And stopped all thinking about it. I don't see that happening.
Right.
But I think we do have some time to go before we have to be alarmed. But still, these are big projects, and they need work right now to build up to the point where if we need them in a hurry, we can put them in place.
Tony Lynch asks, would it be possible to piggyback on a passing meteor to get us out towards Mars or the outer planets with an unmanned mission?
I'm sorry, I didn't quite hear that. Piggyback on what now?
Piggyback on a passing rock.
Oh, sure. That concept has been studied more along the lines of actually capturing a large asteroid and maybe getting inside it, hollowing it out, and using it as a spacecraft. However, Greg Matloff up at CUNY in New York has done some studies on asteroids that make it relatively simple to get to Mars if you could get to them and simply hitch a ride on them. There's a small number, but theoretically, yes, this could be one way we might proceed. You might run a search on the net under that name, Greg Matloff, M-A-T-L-O-F-F. I can't quite remember his numbers on that. It was a paper he delivered about 5 years ago in Italy at a conference I was at. I'm not sure who else has studied that, but it is something that is theoretically possible, yes.
Yeah. I mean, they're ideal, right? You take a rock, you hollow it out, you go inside, you set it spinning, and you pressurize it, and you've got you've got life support, you've got safety from radiation, you've got gravity, you've got all the things that artificial gravity, you've got all the things that will help you make that journey, and you didn't have to get that much mass accelerated to that trajectory in the first place. So
exactly. If we can figure out, again, this whole question of long-term life support, closed life support, a lot of things open up. And this idea, which goes back to a man named Dandridge Cole back in the 1960s, I think it's a very productive idea. And I love it because it uses existing resources rather than our having to build everything. So I think we're going to hear more of it.
Yeah, absolutely. Okay, so let's take a look at a couple of posts that were made by the folks from the WSH crew. And for those of you who sort of don't know what that is the weekly space hangout crew. And this is a great community who sort of talks about the episodes, posts lots of great stories for us to talk about as well. So you can go, it's on Google+, go to WSH Crew, and I'm sure someone will post a link into the comments over on the event page. And I highly recommend that you join them there. And so they posted a few stories, and we only have time for just a couple here, so I just want to get one. One, I think this is sort of in your field, Brian, is Galaxy X. And I guess this is a galaxy made of dark matter.
Yeah, I haven't read too much about it, but I can say not only is it in my field, it's in my university. It's a colleague of mine.
Do you want to go down and just like knock on his door and talk to him, and we'll wait?
Her door.
Her door. Yeah, bring her.
Door. Yeah.
Yeah, maybe next week. How about that?
Nancy actually contacted me, and so to answer Nancy's question, yes, I will talk to her, and you can talk to her, and we'll see if we can get her on.
That sounds great. That's awesome. Okay, so apparently a galaxy made of dark matter has been found, which is great. All right, so Morgan, this comes from Nancy Graziano, actually, and let's talk about the concept of a submarine on Titan.
Yeah, so this is a NASA concept study, and just to kind of put a damper on this right off the bat, a concept study is like half a step above a bunch of engineers sitting around drinking beer, being like, wouldn't it be cool if...
They had an animation.
But the idea here is that we've observed Titan now both from orbit and from the surface with the Huygens lander. But we now know that Titan is covered in some sort of large ocean or series of lakes made up of liquid hydrocarbons. And if you want to explore these oceans and see what might be lurking within or underneath them, the best way to do that would be to send a submarine. And so the idea is to drop a sort of ton-sized submarine into one of these oceans on Titan, and then use a sort of a radioactive power source to power it underwater and swim around in the ocean checking out cool things. Within every day it would surface for a few hours and beam this data back to Earth, and it would just continue basically to swim the oceans of Titan. Obviously this is highly speculative, and there's a lot of things that we need to accomplish before we can do this mission, probably in, say, 50 years or so. But this is an important first step because it kind of gets the ball rolling on people thinking about this in the back of their mind as they go work on other missions and they start making plans for the next 50 or 100 years of space exploration. Titan is one of the places we're going to want to go, and this is an ideal way to check out some of the aspects that we can't see from orbit.
Fantastic. Okay, cool. So let's wrap things up then. We've reached 1 o'clock. We've all got places to go, but let's give everyone a chance to tell us more about themselves. So, Brian Koberlein, where can people find out more about you and your work?
You can find me on my blog, which is briankoberlein.com, or One Universe at a Time. You can find me on Google+. Under my name, you can find me on Twitter at Brian Koberlein.
And your Patreon?
And I have a Patreon account, so if you feel so moved as to support ad-free writing about science, then by all means support me.
Terrific. If you're not already following Brian Koberlein's blog, they're terrific. One blog post a day about the sort of mind-bending physics and debunkery and all that, and it's one of my favorite sites. So,
Cool.
Dave Dickinson, where do people find out more?
Yes, I was active this week on my own site, Astroguys with a Z, and Universe Today and Listosaur, and you can find me out watching for the pass of the International Space Station tonight over the U.S. Northeast at 6:44 p.m. I urge you to get out there. I don't care how cold it is. It's clear tonight, and you can find me getting ready for the next snowstorm, and we cleared the roof off yesterday, and we're ready for Snowmageddon Part 9 here now, or whatever we're up to. So.
Morgan. Where to find more?
Well, right after the show, you can find me over in the Google Plus Space community. Go to plus.google.com, click Communities, and choose Space. I'll answer a lot of the questions I bet we didn't get to today. And if you have any questions about things we didn't even talk about during the show, you can ask them then. You can follow me on Twitter at Morgan Rehnberg, and you can visit my blog at cosmicchatter.org.
So if you missed that, Morgan is going to go to the Google Plus Space community, and he's going to hang out there, and he's going to answer your questions about what we talked about today and anything you can imagine. So why would you pass this up? Go, Google Plus Space community, join Morgan, talk about space. All right, and Paul, of course, we gave you a chance, but let's do one more reminder. Let's go with Twitter this time. So if people want to follow you on Twitter, where do they find you?
Yeah, at Centauri Dreams, it's Centauri_Dreams. That's where I am. I'm glad to talk to you.
Fantastic. Paul, thank you very much for coming today, and open invitation. Anytime you feel like you've got an important story to tell, we would be glad to have you join us.
Fraser, thank you. I have to say I've been following your work. You go back even beyond where I started, and so a great fan here, and it's a real pleasure to talk to you online.
Thank you so much. So before we go, I want to just say one sort of note, which is that we got the news that Tammy Plotner, who was one of our longtime writers for Universe Today, passed away a couple of days ago. Tammy joined us back in, I think, 2004. She was the first writer that I worked with regularly on Universe Today. She went on to write thousands of articles. She wrote two books for us about what's up to see in the night sky for 2006 and 2007. Just an absolute enthusiast for space and astronomy, and she was an absolute treasure. And it's really hard to know that she passed away a couple of days ago. So. I know she would love you to go out and look at the night sky and encourage others to look through telescopes, and so to share that enthusiasm that Tammy had for everything space. So thanks, Tammy. We miss you, and thanks for everything. And we'll see you all next week here on the Weekly Space Hangout. Thanks, everyone. I really appreciate it, and we'll see you next week.
Okay.